Hi children, I am A. Varkavi, working as a Maths CRT in KGBV Lepakshi. Today I am going to discuss about the sets topic in 10th class mathematics. In this video, I will explain about the introduction and exercise 2.1 solutions. Observe this picture, it is the collection of flowers. In this picture, if we bring a marigold, that flower belongs to the collection of flowers. See the second picture, it is the collection of fruits. In this picture, if we bring a banana, we can say that it belongs to the collection of fruits. See the third picture, it is the collection of cell phones. If we bring a TV remote, it does not belongs to that collection of phones. It contains only collection of phones. It contains different types of phones. See the fourth picture, it contains different types of cricket players. In that only cricket players will be there. It does not contain any other persons. Here all these collections are well defined collections. Means if we bring an object, then it should be in a position to say that the particular object belongs to that collection or not. I repeat, well defined means objects in the collection should be in a position to say that the particular object belongs to that collection or not. These are called well defined objects. If we are confused to say whether the particular object belongs to that collection or not, then that collection is not a well defined collection. Then all these four collections are called sets. Let us see some more examples. See the picture. Here, the collection of national leaders is there. In this picture, only national leaders will be there. If I ask the famous leaders, then those members may be in that group or not. So, it is not a well defined collection. See one more example. See this picture. Here all the girls are standing in a line. If I asked a girl sitting in a row, then she is not belongs to that group. That means here only clearly particular condition is there. All the girls are standing. That means there was no sitting girl in this line. So it is a well defined collection. So a well defined group of objects is called a set. Sets topic is introduced by George Cantor. He is a German mathematician who introduced sets. He was born on 1845 March 3rd, died in 1918 January 6th. He belongs to Germany. He worked more in the fields of mathematics, especially set theory. Set theory was introduced by German mathematician George Cantor. Set is a well-defined collection of objects. Sets are represented by capital letters in English alphabet. Example, capital A, capital B, capital C. Objects in the set are called elements. They can be represented by small letters, small a, small b, small c, and so on, small x, small y, small z. All the elements in a set should be kept within the set brackets called braces. See the examples. Capital A containing the elements small a, small b, small c, small d, and the set B containing x, y, z elements, and the set containing capital N 1, 2, 3, and so on elements, and the set W containing 0, 1, 2, 3, and so on. Here the set contains only 4 elements, and the set B containing only 3 elements, the set N containing infinite number of elements, and at the same time W also are containing infinite number of elements. Here we are saying that number of elements, if we can count the number of elements in a set, that set is called finite set. That means we can count the number of elements in that set. And at in the above examples, the sets N and W are also containing the elements, but we cannot count the number of elements. Those types of sets are called infinite sets. Here we are saying number of elements. Number of elements in a set is called a cardinal number. Cardinal number means number of elements in a set. That is called a cardinal number of that set. If the cardinal number is finite, that is called finite set. If the cardinal number is infinite, that is infinite set. Now we will see how to represent a set. What are the different ways are there to represent a set? First one is roster form. In roster form, writing a set by listing out all the elements means we can write the elements only in this roster form. It is also called as list form. Roster form is also called as list form. That means we can just list out the elements in that set, that is roster form. Next way to represent a set is writing a set by characteristic property of elements. Here, writing a set by its characteristic property means here we will write character of the elements, whereas in roster form we will write the elements only. See the example A. The elements in the set A all are vowels in English alphabet. It is also called rule form. In roster form we will write only the elements, whereas in set builder form we will write the rule or property that the elements belongs to that set. Set builder form of the set A can be read as X such that X is a vowel in English alphabet. Another way to represent a set is Venn diagrams. By drawing a closed curve, generally a circle, we will use to represent a set. That means first we will draw a circle. Inside of the circle, we will write the elements in that set. See the example A containing the elements 1, 2, 3, 4. The elements which are interior of the circle belongs to that set, and the elements which are away from the circle does not belongs to that set. Here 1, 2, 3, 4 elements are inside the circle means those elements belongs to that set A, and the element 5 is away from the circle. That means it does not belongs to that set A. See the picture, then we will understand. See the picture. See the picture. Here inside of the circle 4 elements are there. That means those elements belongs to that set. 5 is away from the circle. That means the element 5 does not belongs to that set. In these 3 ways we will represent the sets. What are the forms? Roster form, set builder form, and Venn diagrams. Today we discussed about the set definition and who introduced the sets topic and how to represent a set. Thank you. Hello children. Today I am discussing about exercise 2.1 problems and solutions in sets. See the first question in exercise 2.1. Which of the following are sets? Justify your answers. First one is the collection of all the months of a year beginning with the letter J. Here, what are the given questions? Which of the following are sets? We have to decide the given collections are sets or not. And if the given collections are sets, we have to say the reason why they are sets. And if they are not the sets, we have to write the reason why they are not sets. See the first one, the collection of all the months of a year beginning with the letter J. The collection of months in a year which are beginning with the letter J. What are the months in English year? January, February, March, April, May, June, July, August, September, October, November and December. In these 12 months which are starting with the letter J, January, June and July. See here, the question is clear, means well defined. Here they are mentioning a condition which are starting with the letter J. So that is well-defined collection of objects. So it is a set, and the elements in the set are January, June and July. See the second one, the collection of 10 most talented writers of India. In the India, most talented writers collection is a set or not? We have to decide. It is not a set. Why? Because here the condition is not clear. That is not well defined. So, in my opinion, some persons will be there. In your opinion, some persons will be there. So, here most talented writers means we cannot decide. These are the most talented persons. So, it is not a set and it is not well defined. So, it may vary from person to person. Means, in my opinion, some people are there. In your opinion, they may change. So, it is not a set. See the third question. The third question. A team of 11 best cricket batsmen of the world. Here we cannot decide who are the best cricket batsmen of the world. In my opinion, some may vary. Some persons will be there, and in other persons, in their views, they are different. So we cannot say that these are the best cricket batsmen. These are the topmost 11 best cricket batsmen. We cannot decide. So it is not a set because it may vary from person to person. In my opinion, some people are there. In your opinion, some are there. So this is not a set. This is not a well-defined collection. So it is not a set. That is the reason. Next, see the fourth question. The collection of all the boys in your class. It is clearly mentioned only boys will be in that collection. So it is a well-defined collection. So it is a set. Only all boys will be in that set. See the fifth question. The collection of all even integers. We know that even integers are 2, 4, 6, 8, 10 and so on. Means which are divisible by 2. So those collection is a well-defined collection. So it is a set because only even integers will be in that set. So given collection is a set. See the second question. Here 3 sets are given, and also we have to see the elements and we have to decide the symbols which we are used in the given blanks. Read the question. If A is equals to 0, 2, 4, 6, B is equal to 3, 5, 7, C is equal to P, Q, R, then fill the appropriate symbols belongs to and does not belongs to in the blanks. Belongs to means the elements will be in that set. Then we can use the symbol belongs to. Does not belongs to means if the element is not in that set, we have to use does not belongs to symbol. Here what are the elements in the set A? 0, 2, 4, 6 are the elements of the set A. And what are the elements of the set B? 3, 5, 7. And what are the elements of the set C? P, Q, R. Now see the blanks. 0 dash A means 0 is the element of the set A or not the element of the set A. We have to decide. See the set A. So 0 is the element of the set. So we have to use which symbol? Belongs to or does not belongs to. 0 is the element of A. So we have to use belongs to symbol. 0 belongs to A. Next, see the second one. 3 dash C. 3 is the element of the set C or not, we have to see. C. What are the elements? P, Q, R. Only P, Q, R are the elements of the set C. 3 is not there. So we have to use which symbol? Does not belongs to. 3 does not belongs to the set C. See the third one. 4 dash B. 4 is the element of the set B or not, we have to see. See the elements of the set B. Only 3, 5, 7 are there. 4 is not the element of the set B. So we have to use does not belongs to symbol. 4 does not belongs to the set B. That means 4 is not the element of the set B. See the fourth one. 8 dash A. 8 is the element of the set or not? see the elements in the set A. Only 0, 2, 4, 6 are there. 8 is not there. So 8 is not the element of the set A. So we have to use does not belongs to symbol. 8 does not belongs to A. Next, see the set C. Only P, Q, R are the elements. Here P dash C means P is the element of the set C. So we have to use which symbol? Belongs to. So P belongs to C means P is the element of the set C. See the third question. Express the following statements using symbols. They are given statements. We have to write the given statements using the symbols belongs to and does not belongs to. See the first question in third one. The elements X does not belongs to A. Here the element X does not belongs to the set A. Means X does not belongs to A. We have to use the symbol does not belongs to. Left side of the symbol we have to write the element, and the right side of the symbol we have to use the set name. See the second question. D is an element of the set B. D is an element of the set B. Means the element, here element is written in small letter. So that element belongs to the set B. Means that is an element. So we have to use belongs to symbol. So left side of the symbol we have to use the element, and the right side of the symbol we have to write the set name. See the third question. 1 belongs to the set of natural numbers n. 1 is an element of the set natural numbers set n. So 1 is the element. We have to write the left side of the symbol. N is the set name, and we have to write it in the right side of the symbol belongs to. So 1 belongs to the set capital N. See the fourth question and third one. 8 does not belongs to the set of prime numbers P. What are the prime numbers? Prime numbers means the number which has only 1 and itself as a factor are called prime numbers. Prime numbers means the numbers which are having only 1 and itself or the factors are called prime numbers. Means only two factors will be there, 1 and itself. Suppose if I take 2, what are the factors of 2? 1 and 2. 2 ones are 2. So 1 and 2 are the factors for that number 2. So those type of numbers are called prime numbers. Here what are the given statement? 8 does not belongs to the set of prime numbers. 8 is a prime number or not? 8 is not a prime number. So 8 does not belongs to P. Means 8 does not belongs to the symbol P. Does not belongs to symbol we have to use here. What we have to write on the left side of the symbol element? What is the element here? 8. And we have to write the set name of the right side of the symbol. What is the set name here? P. So 8 does not belongs to P. Next, see the fourth question. State whether the following statements are true or false. Justify your answer. Here some statements are given. So we have to state the given statements are true or false. Justify your answer means we have to write the reason. If we write the given statement as true, why we written that statement as true, we have to write the reason. If we wrote the given statement as false, we have to write the reason why it is false. So see the first question. 5 does not belongs to set of prime numbers. Already I told prime numbers means the number which has only two factors, 1 and itself as a factor is called prime number. So according to that, 5 is a prime number or not? 5 is a prime number. Why? Because 5 ones are 5. So only two factors are there, 5 and 1. So it is a prime number. But what is the given statement? 5 does not belongs to prime numbers set. 5 is a prime number, but they given only it does not belongs to. So it is true or false? False only. So false, the given statement is false, and 5 is a prime number. That is the reason. Like this we have to write the true or false, and also we have to write the reasons for the given statements. So see the second one in this. S is equal to 5, 6, 7. What are the elements in the set S? 5, 6, 7. Implies 8 belongs to S. 8 is the element in the set S is given. Is it correct? 8 is the element in the set? Yes? No. 8 is not there. Only 5, 6, 7 elements are there. So given statement is false. 8 belongs to S is given. Here 8 is not there. So given statement 8 belongs to S is false because 8 is not in the set S. Third one, minus 5 does not belongs to W, where W is the set of whole numbers. What are the whole numbers? The numbers starting from 0, 1, 2, 3, 4 and so on. Those are all whole numbers already we know. In that minus 5 will be there or will not be there. Minus 5 is an integer. So it does not belongs to whole numbers. So it is correct. The given statement is true because minus 5 is not a whole number. So given statement is true. What are the integers here? Integers means including 0, positive numbers, negative numbers or the integers. So in that minus 5 will be there. If the given statement is like this, minus 5 belongs to Z, then the given statement is true. Minus 5 does not belongs to W, it is also true, and minus 5 belongs to Z, it is also true. See the fourth question, 8 by 11 belongs to Z, where Z is the set of integers. Here already we discussed, Z means only integers. What are the integers? Including 0, positive numbers, negative numbers will be there. That means minus 2, minus 1, 0, 1, 2, 3 and so on, positive numbers, and also minus 10, minus 100, minus 1000. Those are all integers. In that 8 by 11 is there or not there? 8 by 11 is a fraction or rational number. It does not belongs to the Z. It does not belongs to integers. It belongs to 8 by 11 belongs to rational numbers. This statement is correct. 8 by 11 does not belongs to Z will be here. But given statement is 8 by 11 belongs to Z, which is false because 8 by 11 is not an integer. Z means integers only. So 8 by 11 is not an integer. So given statement is false. So up to now we wrote only the given statements in symbols only. Next, see the fifth question. Write the following sets in roster form. From here we have to write the set builder form and roster form. See the roster form. Already we discussed about the roster form. Roster form means we have to listing out the elements in the set. See the first question. B is equal to X such that X is a natural number smaller than 6. Here how we have to read this statement is X such that X is a natural number smaller than 6. What are the natural numbers? 1, 2, 3 and so on are the natural numbers. Smaller than 6 means the natural numbers which are smaller than less than 6. What are the natural numbers smaller than 6? 1, 2, 3, 4, 5. 0 will come or not? 0 is a whole number which is not a natural number. So we don't want to take that 0. From 1 only up to 5 we have to write the numbers here. 1, 2, 3, 4, 5. These are the natural numbers which are smaller than 6. Those are the elements belongs to the set B. So B is equal to 1, 2, 3, 4, 5. We have to separate these elements with commas and we have to write the elements in between flower brackets. That is the roster form of the first question. Question second one. C is equal to X such that X is a 2-digit natural number such that the sum of its digits is 8. Here what is the given statement? We have to write the roster form of the X is a 2-digit natural number. That means it contains 2 digits in that number such that sum of its digit is 8. So if I take 17, 1 plus 7. Here 2 digits are there, 1 and 7. Their sum means 1 plus 7 is equal to 8. It satisfied the given condition. So 17 is the element of the set C. Next, likewise, we have to take different numbers. If I take 26, 2 plus 6. Here 2 digits are there, 2 and 6. So 2 plus 6 is equal to 8. So it is also correct. Next, 62. What are the digits in this number? 6 and 2. So 6 plus 2 is equal to 8. Next, take one more, 71. In that 71, what are the digits are there? 7 and 1. So 7 plus 1 is equal to 8. 80 is another number. In that 2 digits are 8 and 0. So 8 plus 0 is equal to 8. So these numbers all are satisfying the given conditions. If I take another number 52, so how many digits are there? 2 digits, which is a 2-digit natural number. What are the digits are there? 5 and 2. Their sum is 5 plus 2, which is equal to 7, which is not equals to 8. 7 is not equals to 8. That means 5 plus 2 sum is not equals to 8. So 52 is not a element in the set C. Why? Because it does not satisfy the given condition. So only these numbers satisfies the given condition. So these are the elements which belongs to the set C. Therefore C is equal to 17, 26, 62, 71 and 80. So see the one more question. Third one, D is equals to X such that X is a prime number which is the divisor of 60. Here divisors, we have to write the prime numbers. We have to write the prime numbers which are the divisors of 60. What are the divisors of 60? Means which divides the number 60 successfully. That means 2. If I take 2 is a prime number, 2 is an even prime number. Prime number means, again already discussed about the prime numbers. Prime number means the number which has only 2 factors. Those are 1 and itself. 2 ones are 2, means only 2 factors are there for 2. 2 itself divides the 2. So 2 ones are 2, 1 twos are 2. So only 2 factors are there for 2, which is a prime number. So if I divide 60 with 2, 2 divides here 60. So 2 30s are 32s are 60. So it divides. So 2 is the prime number which is a divisor of 60. So 2 is the element of the set D. Next, if I take another prime number 3. Okay, let us divide the 60 with 3. So 30 into 20. 23 is a 60, which divides the 60, which is a prime number. So this is also the prime number which is a divisor of 60, and this is the element of the set D. Next, if I take one more prime number 5. 5 divides 60. 12 5 is 60. So which divides the number 60, which is a prime number, and that 5 belongs to the set D. If I take one more prime number, tell me one more prime number, 7. 7 does not divide the set, does not divide the number 60. So next one more prime number, 11. 11 also does not divide the number 60, which is also a prime number. So that is not the element of the set D. Next, if I take one more prime number, 13. 13 also does not divide the number 60. So which is a prime number, but it does not divide the number 60. So it is not the element of the set D. Likewise, we have to check remaining prime numbers also, but only 2, 3, 5 are the elements which divides these number 60. So these are the elements belongs to the set D. Fourth one, what is the given statement? E is equal to, the set E is equal to X such that X is an alphabet in the word better. Here we have to read like this. This symbol is such that. So X such that X is an alphabet in the word better. Better is the word given. What are the letters in the word better? B, E, T, R. Only 4 letters are there. Here E is repeated and T is repeated, but we have to write it as once only. So what is the given statement? The alphabets which are used in the word better. only those letters belongs to that set E. So what are the elements here? B, E, T, R. Likewise, only if the letters are repeated also, we have to write it as once only. So this is about the set E. Next, see the sixth question. Up to now, we wrote only roster form. Now we have to write set builder form. What is the given question? Write the following sets in the set builder form. Some sets are given. We have to write the set builder form for those sets. See the first question. 3, 6, 9, 12. 3, 6, 9, 12. Listen, 3, 6, 9, 12. What are these numbers? Multiples of 3. So what are the multiples of 3? 3 ones are 3. 3 twos are 6. 3 threes are 9. 3 fours are 12. 3 fives are 15. 3 six are 18. 3 sevens are 21. Likewise. Those are the multiples of 3. Here only 4 multiples are given. 3, 6, 9, 12. So how can we write the set builder form for this set? X such that x is a multiple of 3. Those are the multiples of 3 and less than 15. Below 15, the elements are given in that set. So x is less than 15. So 3 is less than 15, 6 is less than 15, 9 is less than 15, 12 is less than 15. So like this we have to write the set builder form for this first question. 3, 6, 9, 12. In exams they can also ask like this. 2, 4, 6, 8, 10. That means those are the multiples of 2. So likewise they may ask any question, but we have to learn the method how to write the set builder form for these multiples of some numbers. Okay. Next, see the second question. 2, 4, 8, 16, 32. These are the elements given. Observe these numbers. These numbers are like this. 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. In this form, these elements are there. So, how can we write the set builder form for this? X such that x is equals to 2 power n. That means these numbers are in the form of 2 power n. N means here 1, 2, 3, 4, 5. Their powers are the natural numbers. So, we have to write the n belongs to capital N. That means this is small n. That means the powers belongs to the natural numbers. Powers are natural numbers. And n is less than or equals to 5. That n value is less than or equals to 5. Here 1 is less than 5. 2 is also less than 5. 3 is also less than 5. 4 is also less than 5. 5 is equals to 5. So we have to write the condition. N is less than or equals to 5. So 2 power 1 means 2 only. 2 square is 2 into 2, 4. 2 cube, 2 into 2 into 2. We have to multiply this 2 by 3 times. So 2 into 2 into 2 is 8. 2 power 4. 2 into 2 into 2 into 2. So 16. We have to multiply this 2 by 4 times. And 2 power 5 means 32. We have to multiply this 2 by 5 times. So that is 32. These are the elements belongs to this set, and the set builder form for this set is x such that x is equals to 2 power n, and this small n belongs to the natural numbers, and that value is less than or equals to 5. Here n value is 1, 2, 3, 4, 5 only. This is the set builder form for this given set. See the sixth question, third one. 5, 25, 125, 625 are the elements. Here observe these elements. 5 means 5 power 1. 25, that is 5 square. 5 into 5, 25. And 125 can be written as 5 into 5 into 5, that is 5 cube. 625 can be written as 5 into 5 into 5 into 5, that means 5 power 4. That means we have to multiply this 5 by 4 times itself. So according to this, x is such that x is equals to 5 power n, I can write. Here n is a natural number. N is equals to 1, 2, 3, 4. N belongs to the natural numbers, and natural numbers are starting from 1 only, and that value is less than or equals to 4. Means here only 1, 2, 3, 4 numbers we are taking. So the condition for that is n is less than or equals to 4. Here 1 is less than 4. If I take n value as 2, 2 is less than 4. If I take n value as 3, 3 is less than 4. If I take n value as 4, 4 is equals to 4. So this is the condition which satisfies these values. So the roster form, the set builder form for this set is x such that x is equals to 5 power n, where n belongs to the natural numbers and n is less than or equals to 4. 5 power n is 5 power 1, so 5. 5 square, if I take the n value as 2, 5 square is equals to 5 into 5, 25. If I take n value as 3, so 5 cube, 5 into 5 into 5 is 125. If I take n value as 4, 5 power 4 is equals to 5 into 5 into 5 into 5, which is equal to 625. This is the set builder form for this roster form. Have you understood? Next, see the fourth question. What are the elements given? 1, 4, 9, 16, 25 and so on up to 100. Observe these numbers. 1 can be written as 1 square, so 1 into 1. Next 4 can be written as 2 square, 2 into 2. 9 can be written as 3 square, 3 into 3. 16 can be written as 4 square, 4 into 4. 25 can be written as 5 square, 5 into 5. And so on like this. 6 square, 7 square, 8 square, 9 square will be also there in this set. And 100 can be written as 10 square, that is 10 into 10. So according to that we can write like this. X such that x is equals to n square. Here n value belongs to the natural number. So what are the natural numbers? 1, 2, 3, 4, 5 and so on. And that value n, the value of n is less than or equals to 10. Less than or equals to 10 means up to 10. From 1 to 10 we can take the values of n. Those are 1, 2, 3, 4, 5, 6, 7, 8 and so on up to 10. So if I take the value of n as 1, 1 square can be written as 1 into 1, which is equal to 1. Next, if I take the value of n as 2, 2 square, 2 into 2, 2 2s are 4, which belongs to this set. If I take the value of n as 3, 3 square can be written as 3 into 3, that is equals to 9. Next, another number is 4, 4 square can be written as 4 into 4, 4 4s are 16. If I take the value of n as 5, 5 square, 5 into 5 is equals to 25. If I take the value of n as 6, 6 square, 6 into 6, 36 will be in this set. If I take the value of n as 7, 7 square can be written as 7 into 7, 7 7s are 49, which also belongs to this set. Next, another value is 7 after 8. If I take the value of n as 8, 8 square can be written as 8 into 8, which is equal to 64. That also belongs to this set. Next, another number is 8 after 9. 9 square is equals to 9 into 9, which is equal to 81, which also belongs to this set. Next, another number is 9 after 10. 10 square can be written as 10 into 10, which is equals to 100. So these are the elements belongs to this given set. And the set builder form for this set is x such that x is equals to n square, where n is a natural number, n belongs to capital N, and the value of n is less than or equals to 10. This is the set builder form for this given roster form. Write the following sets in roster form. Again they are asking roster form for the given sets. What is the question? A is equal to x such that x is a natural number greater than 50 but smaller than 100. Here these are the natural numbers. The natural numbers are starting from 1, 2, 3 and so which are greater 50, smaller than 100. So greater than 50 we have to write the 50 will be set or not. 50 is not will be there. Because greater than 50 only we have to write. What are the greater numbers of 50, 51, 52, 53, 54 and 1 up to 100 and 101 also will be there. But here the condition is smaller than 100, below the 100 and above the 50 only we have to write. Then what are the numbers will come here? 51, 52, 53, 54, 55, 56, 57, 58, and so on up to 91, 92, 93, 94, 95, 96, 97, 98, 99. But 100 will not be there. Why? Because smaller than 100 means only up to 99 only we have to write. So what is the set roster form for this set builder form? A is equals to 51 through 53 and so up to 29. These are roster form for this given question. The second one, b is equals to x such that x is an integer, x square is equals to 4. Here x is the element which belongs to the integer. Integers means including 0, positive numbers, negative numbers also come. So 0, minus 2, minus 1, minus 4, next plus 1, plus 2, plus 3, plus 4 and so on. Positive numbers and negative numbers including 0 or the integers. Here such type of integers will come in this set. And what is the condition? Those integers must satisfy the condition x square is equals to 4. If we take a square of the integers, we have to get 4. So those elements will come only in this set. So if I take 0, 0 square is 0 into 0, that is equals to 0. So this is not equals to 4. Then 0 is not the element in this set B. If I take 1 square, so 1 into 1 is equals to 1. 1 also not equals to 4. So 1 does not belongs to this set B. If I take 2 square, its square is 2 into 2, that is equals to 4, which is equal to 4. So this 2 belongs to this set B. If I take minus 1 whole square is equal to minus 1 into minus 1, which is equal to plus 1, not equals to 4. So this minus 1 does not belongs to the set B. If I take minus 2 whole square, x square means minus 2 whole square. So that is minus 2 into minus 2, which is equal to minus into minus plus, and 2 into 2 is 4, which is equal to 4. So minus 2 and plus 2, these are the elements belongs to this set B. If I take minus 3 whole square, minus 3 into minus 3, which is equal to 9, which is not equals to 4. Therefore, minus 3 does not belongs to the set B. Likewise, we have to check all the integers, and those integers must satisfy this condition. That means their square, the integer's square must be equals to 4. Those type of elements only belongs to this set B. Now, what is the roster form for this? Only minus 2 and plus 2. These are the elements belongs to this set B. Have you understood? Next, see the third question. D is equals to x such that x is a letter in the word loyal. Here one word is given, that is loyal. What are the elements? What are the letters in that word? L, O, Y, A, L. But we have to write only once. If a letter is repeated also, we have to write it as once only. So L, O, Y, A. These are the letters used in this word loyal. Then what are the elements for this set? L, O, Y, A only. So this is the roster form for this set D, set builder form. Here the next question, 8th one. Match the roster form with set builder form. Here roster forms and set builder forms are given. We have to match these roster forms with the set builder forms. See the first one, 1, 2, 3, 6. Here the elements of the set are 1, 2, 3, 6. See the first option A. This is a prime number, divisor of 6. Prime numbers and divisor of 6. What are the prime numbers and divisor of 6? What are the divisors of 6? 1, 2, 3, 6. Already given. So 1 divides 6. 1 6 are 6. And 2 3s are 6. 2 also divides the number 6. 3 also divides the number 6. 3 2s are 6. Next 6 1s are 6. So these are the divisors of 6. But here only prime numbers are there, 2 and 3. But here 1 2 3 6 are there. So this is not the correct option. See the second one, 2 comma 3. These are the prime numbers in these divisors, 2 and 3, which is a prime number, and divisor of 6. 2 is a prime number and divisor of 6. 3 is a prime number and divisor of 6. So first 2, A is the correct answer. So for this second question, A is the correct option. Next, see the option B. X is such that X is an odd natural number smaller than 10. Odd natural numbers smaller than 10. What are the natural numbers? Natural numbers starts from 1 only. 1, 2, 3, 4, 5, 6 and so on. And odd natural numbers. What are the odd natural numbers? 1, 3, 5, 7, 9, 11, 13 and so on. Odd numbers means the numbers, if we divide a number with 2, then the remainder will 1. That means they are not divisible by 2. The natural numbers which are not divisible by 2 are called odd natural numbers. Here 1 is not divisible by 2, 3 is not divisible by 2, 5 is not divisible by 2, 7 is not divisible by 2, 9 is also not divisible by 2. So these are all odd natural numbers and which are smaller than 10. So which are smaller than 10? 1 is less than 10, 3 is less than 10, 5 is less than 10, 7 is less than 10, 9 is less than 10. So correct answer, correct roster form, set builder form for this roster form will be B. The set builder form for this roster form is B. Next, see the option C. X is such that X is a natural number and divisor of 6. Here these are the natural numbers 1, 2, 3, 6 and these are the divisors of 6. So the set builder for this roster is C. Next, last option. X is such that X is a letter of the word mathematics. What are the letters in the word mathematics? M, A, T, H, E. M already repeated, E already repeated, T already repeated. Next, I, C, S. So these are the letters we are using in the word mathematics. So M, A, T, H, E, I, C, S. These are letters in the set. In this set. So this is the correct set builder form for this roster form. So correct option is D.